So there was a great debate in 1920. I'll go ahead and read this out to you guys. I'll link it to the bottom. It's off a NASA.gov website or page here. Although the great debate is important to different people for different reasons, it is a clear example of humanity once again striving to find its place within the cosmic order. In the debate, Shapley and Curtis truly argued over the scale of the universe. This is just scale and size. As the debate's title suggests, Curtis argued that the universe is composed of many galaxies like our own, which had been identified by astronomers of his time as spiral nebulae. Shapley argued that these spiral nebulae were just nearby gas clouds and that the universe was composed of only one big galaxy. In Shapley's model, our sun was far from the center of this great universe galaxy. In contrast, Curtis placed our sun near the center of our relatively small galaxy. Although the fine points of the debate were more numerous and more complicated, each scientist disagreed with the other on these crucial points. And to review this, the scientists disagree. That's great. Good. A partial resolution of the debate came in the mid-1920s. Using the 100-inch Hooker telescope at Mount Wilson, then the largest telescope in the world, astronomer Edwin Hubble identified Cepheid variable stars in the Andromeda Galaxy, M31. These stars allowed Hubble to show that the distance to M31 was greater than even Shapley's proposed extent of our Milky Way galaxy. Therefore, M31 was a galaxy much like our own. In the 1930s, the further discovery of interstellar absorption combined with an increased understanding of the distances and distribution of globular clusters ultimately led to the acceptance that the size of our Milky Way galaxy had indeed been seriously underestimated and that the sun was not close to the center. It's in one of the outer bands, one of the outer arms. Therefore, Shapley was proved more correct about the size of our galaxy and the sun's location in it. But Curtis was proved correct that our universe was composed of many more galaxies, and that spiral nebulae were indeed galaxies just like our own. And here's the whole point of this talk I want to talk. This is mainly for Baz. Another reason the great debate is important is captured nicely in the book Shu F. 1982. Shu. I don't know why his name's Shu, but that's his last name, whatever. The Physical Universe. An Introduction to Astronomy, yada yada yada, page 286. Quote, the Shapley-Curtis debate makes interesting reading even today. It is important not only as a historical document, but also as a glimpse into the reasoning processes of eminent scientists engaged in a great controversy for which the evidence on both sides is fragmentary and partly faulty. This debate illustrates forcefully how tricky it is to pick one's way through the treacherous ground that characterizes research at the frontiers of science. Let me read that out again for you guys. This debate illustrates forcefully how tricky it is to pick one's way through the treacherous ground that characterizes research at the frontiers of science. And this is because evidence on both sides is fragmentary and partly faulty. I know this fully well. Baz, I know you're currently working on the magnetic field stuff, and I'll be honest with you, man, it's hard. A lot of that stuff is way over my head. So for you to do graphics on it is exemplary. It's far over my head, I'll admit that. And a lot of the information concerning white dwarfs and how stars are actually born is far over my head. I'm not sure how they're born, Baz. I'm not sure. A lot of the information I have is faulty and fragmentary. But I place them at the beginning of solar evolution. That's the real weak spot I have there. I'll admit that. And the reason why it's weak is because I know what happens to stars as they cool and evolve and die. They become large gaseous objects which collapse upon themselves and form their cores, become planets. We all know this. It's tried and true. It's obvious. That's not the point. That's not the point. That was the discovery I made. The point is, I know what happens to stars when they die. So for astronomers to say white dwarfs are dead stars, what? Clearly they're not dead stars. Something else is going on there. And that's the clue that I had from the discovery that was made. A lot of other clues like that pop up when you take the discovery and you take its honest to God conclusions to their full extent. What you end up doing is seeing a whole bunch of things surrounding you that are false, that astronomers have been making up, and they won't realize that they're false because they still hold the false assumption that the discovery already replaced. I don't know how else to word that. I want to say it again because that's a mind-numbing idea. But basically, what I want to get to you guys, Baz especially, is that all the information I have concerning the processes that I'm discussing in these videos and the papers I write is partially faulty. I'll admit that, and I've always admitted that. Stellar birth is a weak spot. White dwarfs are a weak spot. As well, one of the deep-seated ideas I have here, and this is the second part of this talk, is we're trying to find our place within the cosmic order. I think we're all trying to strive to see what the next step is. Where do we go from here? What does all this mean? Who are we? Yada, yada, yada. And the Great Debate was important because it had set a understanding of how freaking far away these things are. The Andromeda Galaxy is 2.5 million light years from us. I can't even imagine that distance. A light year I can't even imagine the distance of, but 2.5 million light years. That thing is far, far, far away. There could be Star Wars happening in that galaxy. We wouldn't even realize it. That's how far away that thing is. But on the other hand, that is a size variable, the magnitude in size, actual distances. But there is another magnitude of distance that astronomers sort of they fail miserably at, and that's age. The ages of these objects that are in our own solar system even are wildly different. And if you look up on any Wikipedia article or any article online, they say Mercury, Mars, Venus, Earth, Neptune, Jupiter, Saturn, Uranus, they're all 4.5 billion years old. That's very Earth-centric of them to claim that they're all the same age as the Earth. The sun's the same age, all the moons, all the asteroids, they're all the same age. No way. What I realize is that not only are the distances really vast in the universe, the scales of time are extremely vast. I'll link this paper to the bottom, but I have Mercury as being 327,500 times older than the sun. But the astronomers say Mercury is about the same age as the sun. When clearly, with anybody looking at the sun, through welding goggles, hopefully, they can see that that's not an old object. And if you were to look at Mercury, a picture of the messenger probe looking at its surface, you can see that it has a tortured surface with all those cratering marks, and it just looks like a dead world. Why would astronomers take the sun and Mercury and place them at the same age confounds me. I think it should have been common sense that those objects are wildly different in age. And this age is based off the gyrochronology measurements that I had calculated. I'll link it to the bottom. Where Mercury sits in the Walensky-Taylor diagram, it's about right here. Way the hell over here. Probably a little bit lower, probably a little bit over here, but still in this general area. That thing is at least 32.5 trillion years old, if not between 7 to 32.5 trillion years old. And those scales of time are important to realize, is because, yeah, the Earth is 4.5 billion. That's old. That's really freaking old. But the objects in the universe are not based on the Earth. We shouldn't be looking at the time scales for the objects in the universe as being Earth-centered. As well, you can tell how ridiculous it kind of is because the Big Bang supposedly is 14 billion. So what they're saying is Earth is 1/3 the age of all of existence? Come on, man. Can't people see how ridiculous that is? And it's just another step forward to understand our place in the cosmos, is to understand how old these things are. Sure, if you see a centurion, a person that's 101, 102 years old, they're old from our standards. But to really, really use your brain remember that this universe is more than likely eternal. So it means objects in it really, they just lose all meaning that they become so old. And Mercury is one of those objects as to where it's so old, it's a fossilized dead remains of a star that's long been completely solidified, and it's just been wandering the galaxy, getting beat up by asteroids and what have you. If only astronomers can realize this. Anyways, I think I made this video long enough. Hopefully you guys read these articles on this stuff, and to really look out at the stars in a different way, not just in terms of size, but in terms of time. It's really old stuff out there, far beyond Earth's little short existence, even though Earth is 4.5 billion years old. Alright guys, later.